In this video, we're going to take a look at an introduction to recurring decimals to fractions. Now, to begin with here, let's just discuss what a recurring decimal is. And hopefully you are familiar with this concept, but if you aren't, don't worry. So a recurring decimal is just a decimal number that repeats infinitely. So this recurring decimal here, so this is 0.6 with this little dot over it, or over the digit here, this 6. So what this means is the 6 keeps repeating infinitely. So in other words, what this would be is 0.6, 6, 6, 6, 6, and so on. And that's the basic idea of what a recurring decimal is. Now, recurring decimals can be difficult to work with unless we can get them as a fraction. And that's the idea with this topic. Okay, so we're going to convert recurring decimals to fractions. Now, just discussing the notation here. Again, sometimes you might not see a dot, you might see a bar. I think that's quite rare. You don't really come across it, or certainly not in the UK anyway, but it can happen. So you might see, for example, 0.12. So if the 12 here is recurring, these two digits here, then you might see a bar. That is a way of representing it, but normally what you'd see, certainly in the UK anyway, is two dots over it, so like so. Okay, and that would mean the 1 and the 2 recurring, so this would be 0.1, 2, 1, 2, 1, 2, and so on. Okay, so that's a very basic kind of introduction to what a recurring decimal is. Let's take a look now at how we convert recurring decimal to a fraction. So let's clear everything on the screen. So let's start with this one here. So I've got the recurring decimal 0.6 recurring. And I want to prove that this can be written as 2 over 3. Now what we do here is we say that our recurring decimal here, 0.6 recurring, can be expressed as some algebraic element. Let's say x. Okay, so we say that x is equal to 0.6 recurring. So what I'm going to do is I'm just going to write this out to a few decimal places, something like that. Okay. And the reason we do this is because what I want to do is find a power of 10 here once I times it by x. So I'm going to times x by 10 to start with. So I'm going to get 10x. Okay, so that's going to give me 10x. And what I do now is I times the right hand side here by 10 as well. If I times it by 10, all that happens is my decimal place moves up one place to the right. So I'm going to get 6.6, 6, 6, 6, 6, and so on. And the reason I do this here is because what I want to do is I want to match the decimal places. Okay, so everything after the decimal point here. Okay. And it works in this case because I just get digits of 6 on the right hand side of my decimal when x, or when it's for x here, and the same for 10x. Okay, so everything to the right of my decimal place is, or my decimal point here, is a 6. And once you get a matching like this, we're on to a winner, because what I'm going to do now is I'm going to call this equation 2. I'm going to call this equation 1. I'm going to subtract equation 1 from equation 2. So we've got 10x here is equal to 6.6, 6, 6, 6, 6, and so on. And we're going to subtract x here, which is equal to 0.6, 6, 6, 6, 6, and so on. Okay. So on the left-hand side, if I do 10x minus x, hopefully nice and straightforward, some basic algebra here, that would give me 9x. Okay, so that's 9x. Now on the right-hand side here, don't overcomplicate this. If I've got 6.666 repeating here, and I subtract 0.6 here, repeating again, or recurring, then all that's going to happen is everything after the decimal point here will just disappear. Okay, because I'm just subtracting 0 from the 6 here. These will all disappear, they'll cancel with those. I just get left with 6. Okay, so 9x is equal to 6. Now I just want x here. Okay, so what I'm going to do now is divide by the coefficient of x, which is 9. So x is equal to 6 over 9. And we can simplify this here. 6 over 9. 3 goes into both my numerator and my denominator here. So it goes into my numerator 2 times. And it goes into my denominator 3 times. And we get 2/3 there, exactly as the question wanted us to show. Okay, so that's 2/3 as required. Okay, so therefore, what we can say then is our recurring decimal, so 0.6 recurring here, is equal to 2 over 3. That's what we've shown there. And that's our solution. So there you can see the process is quite straightforward. It can certainly get, trickier than this, and we'll see that in the next video when we take a look at some exam style questions. But hopefully that didn't seem too challenging. So let's take a look at another question then, this time now where we have these two digits that are recurring. So again, we just say that x is equal to 0.12 recurring, so that's 0.12, 12, 12, and so on. Okay. Now again, what I do is I start by timesing x here by 10, so I get 10x, and move our decimal point up one place. So what I'm going to get then is 1.212121, and so on. Now the issue here is if we take a look at everything to the right of our decimal points, they don't match. This is 121212. This is 212121. So what I do here now is I times by 10 again. So I times 10x by 10, I get 100x. Okay. And what I'm looking to do here is match with the original x. Okay, so this is the key one here. We need to match everything to the right of our decimal point here with either 10x, 100x, 1000x, so on. So timesing by 10 again, move our decimal point up one more place. So now I'm going to get 12 point, and now it's going to be 1212, and so on. So 121212. Okay, that keeps recurring or repeating. Now, if we notice here, everything to the right of our decimal point is the same as everything to the right of this decimal point for x. So in that case now, we found a match. What we do now is we subtract. So I'm going to take my 100x here, call that equation 2, call this equation 1. I'm going to subtract equation 1 from equation 2. So I've got 100x is equal to 12.121212. And we're subtracting x here. So subtracting x, which is equal to 0.121212, and so on. Well, hopefully the left-hand side here is nice and straightforward. 100x minus x, that would give me 99x. Okay. And subtracting here, I've got 12.121212. Everything to the right of this decimal point will subtract to everything to the right of this decimal point. They just cancel. They just cancel. And I just get left with 12 minus 0, giving me 12. Okay. So I've got 99x is equal to 12. We just want x here, so we divide by this coefficient of x. So therefore, x is equal to 12 divided by 99. Now, this isn't quite what we were required to get. We wanted to get 4 over 33. But if we look at what we've got here, we can easily obtain that. Okay. If we divide top and bottom here, then we can easily get what they've got here. So therefore, if we divide top and bottom here by 3, then 12 divided by 3 would give me 4, and 99 divided by 3 would give me 33 there. Okay, so we get 4 over 33 as required, and therefore what we can say then is 0.12 recurring is equal to 4 over 33. Okay, that's our solution to the second question. Moving on to the last question now, pretty similar. All I want to do is show that this recurring decimal can be expressed as 43 over 99. Now, all we do here again is we take our recurrent decimal and call that some kind of algebraic expression. Usually we just pick a variable such as x. So we say that x is equal to this recurring decimal. So 0.434343. And the first thing we do is we times this by 10 to get 10x. So we get 10x. And we move our decimal point up one place to the right, so that's 4.3434, like so. Okay. Now we compare everything to the right of both of these decimal places, or these decimal points, sorry. Well, they don't match. I've got 4343, so on. This is 3434, and so on. So they don't match. Now remember, what we're going to do is match with our original expression here. So we times this 10x again here by 10, and that would give me 100x. And we make sure that we times the right hand side as well by 10. So move the decimal point up one place to the right. So we're going to get 43.434343. Okay, and so on. So these are all so on, they keep recurring. So at this point now, compare this 100x to our original x here. And we notice that after the decimal point, they match. So because they're a match now, we can perform our subtraction. If we call this equation 2 here, and we call this equation 1, then we're going to subtract equation 1 from equation 2. So let's write that here. So 100x, which is equal to 43 recurring here, or 43.43, and so on. We're going to subtract x here, which is equal to 0.434343. Okay. Again, this should hopefully be getting pretty standard at this point now. Just doing the subtraction. On the left hand side, 100x minus x, that would give me 99x. And on the right hand side here, everything after decimal points will cancel, and I'll get left with 43 minus 0, which is just 43. Okay, so we get 43 there. Now we just want x, we divide by the coefficient of x here, so x is equal to 43 over 99. And notice that that is exactly what we wanted to show here for our final expression. So what we can say then is 0.43 recurring is equal to 43 over 99. Okay, and there we have it. So that's our solution, and that brings us to the end of this video on recurring decimals to fractions. In the next video, we're going to take a look at some exam style questions, some trickier questions for recurring decimals to fractions.